Travis, and I'm a rising senior at Regis High School, and this is my 3-joint robotic arm. I chose to do this project because I'm interested in working in prosthetics, and even though this is much simpler than any prosthetic arm that a human would want attached to them, I thought it would still serve as a good introduction to that field. So what exactly does it do? It's an arm. So what these gears do, they work with mechanical power, so you have to turn it yourselves, but you can rotate the arm this way, that way, so say, depending on where you want to grab it. These servos each control a joint, so this is the first joint, second joint, the third joint, and opening and closing the hand. And so the way that works is, so when I enter something into the serial monitor, which is in the Arduino, it prompts me to enter a value. So say I want to change the base to go this way. Then I type button, it goes that way. Say I want this joint to also bend down that way. It bends down. Say I want this one to say I want this one to go up. I think it's this key. It is that key. It'll go up. I want to grab something that happens to be at this point in space. And then to close it, yeah, ow. The steps I took to do this, the first step I was to code the servos. So the way I have it set up, I think I described it already, but I'm prompted to enter value. I enter that value, and then if and only if that specific value matches the value that corresponds to the servo, it will turn that servo. And so if I enter a value that does not correspond to anything, the arm just won't do anything. The next step was to cut the metal pieces of the arm. I did this, I used 3D modeling software on the computer, and I marked up the metal to cut it using power tools. Yeah. The final part was to make the base. Just having the arm here by itself wouldn't really work because it wouldn't have anything to stand on. So I attached everything together. I attached the servos onto the metal onto the wood, mounted the wood together so it was nice and sturdy, and yeah, that's how I built it. The greatest challenge I faced actually had to do with the planning phase. So servos are not really that strong, and what I found out is that when you're given the weight when you know how much your thing weighs, and you know the strength of your servo, which is in the product information, you can actually calculate the maximum horizontal distance that the servo can support. So just to show you, when I did the math and all the physics and fun stuff, I found that one of these servos can only hold 12 inches worth of weight. And so this part of the arm just by itself is 14, and the whole thing is 2 feet. And so one servo alone, it would just break if it tried to do all that weight. And so maybe you're wondering what all these random holes are on my arm. And unlike jeans, they're not a fashion statement. Adding holes doesn't make them super cool or anything. What the holes serve, their purpose is really just to decrease the weight of the arm. So even though this is 14 inches of metal, it feels like it's only 10 inches, and the servo can support all 10 inches. Similarly, down here, I have 2 servos, so that's double the turning force, which means it can support 24 inches instead of 12. Looking back at my experience at Bootstrap, I learned a lot about myself and what I wanted to do. Coming into the program, I wasn't even sure if I wanted to be an engineer, and I was really scared I was going to go to some expensive college and drop out of the engineering program. That would be really bad. And what I learned is that I do not like coding. I have mixed feelings about electricity, but I really love mechanical. Like, I just started playing with responsibly using the power tools, and I just had that I can walk out of Bootstrap knowing for sure that I want to be a mechanical engineer. Thank you. How did I calculate it? So the formula for torque is the torque is equal to the force of the weight times the horizontal distance. And so the force of the weight is just the mass of the metal times the acceleration due to gravity. And so you're given the torque of the motor on the website and the specs about this, and you measure the weight either by measuring, you find the weight by measuring how much this is and then multiplying it by little g. And you can, since you have 2 variables, you can find the distance with just a simple algebra.
Math question. It's got a lot of holes in it.
It does.
Oh, you explained that?
Yeah, I did.